There is a photograph from 1904 of the inside of a generating station in upstate New York. The turbines are enormous, the ceiling is vaulted, tall arched windows line both walls, and light comes through in long diagonal shafts the way it does in old European churches. The caption says it is a power plant, but nothing about the building looks industrial. It looks like someone built a cathedral and placed the machinery inside, almost as an afterthought. The workers standing beside the equipment are very small. The building above them is very large. That detail does not go away. There is a particular kind of photograph that appears repeatedly in the archives of American utility companies from the late 1880s through the early 1920s. The subject is always a generating station or turbine hall. The setting is always industrial: wires, pipes, massive rotating machinery, the physical apparatus of a new technology being installed for the first time in American cities. But the building surrounding that machinery does not read as industrial at all. The ceilings are vaulted, the windows are arched, often rising the full height of 2 stories, arranged along the walls with the careful spacing you find in Romanesque churches. The floors are finished stone or polished tile, not bare concrete. The proportions of the rooms follow a geometry that has nothing to do with where the turbines needed to sit or how the workers needed to move between them. And in the foreground of nearly every photograph there are men. They are not posed for dramatic effect. They are standing near the equipment, doing their jobs, and the effect of their presence is accidental and complete. They are very small. The machines behind them are enormous. The building above them is larger still. Consider the measurements. A worker standing beside one of the Westinghouse turbines at the Fisk Street station in Chicago in 1903 reached approximately to the base of the machine housing. The window behind him began above his head and ended near the ceiling, 30 feet up. The turbine hall at Fisk Street measured 210 feet long and 97 feet wide, with a clear interior height sufficient to contain a 5-story building inside its walls. The mechanical function of that space required none of those dimensions. The turbines generated identical output in a lower ceilinged room. The scale was not an engineering decision. It was something else. This is not one building or one city. William Stanley, the engineer who designed the first successful alternating current distribution system in Great Barrington, Massachusetts in 1886, installed his equipment in a converted barn. The system worked. The barn had no arches, no stone walls, no ceremonial proportions. 9 years later, the Adams Power Station at Niagara Falls, which carried the first large-scale transmission of alternating current in American history, was housed in a building designed with arched windows, decorative brick coursing, and an entrance pavilion scaled like a civic monument. Contemporary accounts describe it as the most significant electrical installation in the world. The building was designed as if the technology it housed already belonged to a record older than itself. In Milwaukee, the generating station completed by the Milwaukee Electric Railway and Light Company in 1902 featured a turbine hall with a barrel-vaulted ceiling and windows of a scale and quality that architectural historians have since noted exceeded any functional requirement. In Detroit, the Connors Creek Power Plant, begun in 1914, was designed with exterior brick detailing and arched window groupings that gave it the civic presence of a public bathhouse rather than a private electrical facility. In Waterbury, Connecticut, and in Spokane, Washington, the same vocabulary appears in generating stations built by private utility companies with no municipal obligation and no public audience for the architectural statement they were making. The geographic range matters. This was not a regional aesthetic or the preference of a single firm. The engineers and architects who designed these buildings worked in different cities for different clients under different financial pressures. They did not coordinate their choices, and yet the choices converge on the same language. Arched openings, vaulted ceilings, masonry of a quality and thickness that exceeded anything structural calculations required. Ceremonial symmetry in facades that belong to civic institutions, not commercial ones. What is absent from these buildings is as significant as what is present. There are no advertising signs on the early facades, no temporary materials, no corrugated metal or wood-framed infill of the kind that characterized ordinary industrial construction in the same period. The walls of several surviving generating stations from this era are 18 inches thick, masonry built to the standards of courthouses and municipal waterworks, not equipment enclosures. An 18-inch brick wall does not protect machinery more effectively than a 12-inch one. It signals something about how long the institution inside expects to stand. The construction in these buildings was intended to outlast the equipment inside it. The equipment was expected to be replaced as technology advanced. The building was not. Industrial buildings in America in this period were understood as functional enclosures for changing processes, built to be demolished or converted when the machinery they housed became obsolete. These generating stations were built on entirely different assumptions. They were built the way civic institutions were built, as though what happened inside them was permanent and worth marking in stone. The machinery they housed had no historical precedent and no prior claim on the language of permanence. The buildings surrounding that machinery were designed in a vocabulary that communicated institutional authority extending back centuries. The design exceeds, in every measurable way, what the equipment required. Something in the decision to build these stations this way points toward a purpose that engineering alone cannot explain. The official explanation for why these buildings looked the way they did is not unreasonable. Historians of architecture and technology have offered it consistently, and the individual pieces of the argument hold up under examination. Electrical power in the 1880s and 1890s was genuinely frightening to the public. It was invisible, it was lethal, and it had arrived without any cultural framework for managing it. The utilities constructing these early generating stations understood that public acceptance was not guaranteed. A building that looked substantial, permanent, and civic sent a message that the enterprise inside it was equally substantial and trustworthy. The architecture was institutional reassurance, and the strategy was deliberate. When Samuel Insull took control of Chicago Edison in 1892, he described the company's public-facing infrastructure as part of its argument for public acceptance. The buildings were not incidental to that argument. They were the argument made visible. There were also practical reasons. Electrical generating equipment ran continuously, generated heat, and carried real fire risk. Masonry construction was fireproof in a way that wood-frame industrial buildings were not. Several major generating stations of the 1890s had been damaged or destroyed by fire before utilities standardized on brick and stone. The insurance underwriters who set premium rates for electrical facilities made the financial case for heavy masonry more compellingly than any architect. The thickness of the walls was not only ceremonial, it was actuarial. And there was the civic pride argument, which architectural historians have documented across dozens of specific projects. American cities in the progressive era competed actively for the markers of modernity. A municipally owned electrical utility that looked like a public institution, dignified, permanent, worthy of the city it served, expressed civic ambition as much as practical function. The Pratt Street Power Plant in Baltimore, completed in 1900, was a municipal project designed by the firm of Baldwin and Pennington, better known for railroad terminals and public buildings. Its arched windows and decorative brickwork were acknowledged at the time, in contemporary newspaper accounts, as an intentional statement about the city's relationship to the new technology. That explanation is coherent. It accounts for most of the evidence most of the time. The one detail that nagged researchers examining the full-built record was not any single building. It was the repetition. Not just grandeur, this specific kind of grandeur. The arched nave, the clear-story windows, the processional axis from entrance to primary machinery, the proportional relationship between height and floor area that mirrors the interior geometry of basilica churches rather than the contemporary factory buildings of equivalent function. This vocabulary appeared not only in the prestige projects of major cities, it appeared in transformer substations in secondary neighborhoods of mid-sized industrial towns. It appeared in switching houses and boiler rooms where no public audience existed and no civic statement was intended. A transformer substation built in Racine, Wisconsin in 1909 by a private utility serving a residential neighborhood was designed with the same arched window groupings that appeared on the Adams station at Niagara Falls. No utility ratepayer ever looked at that building. Someone designed it that way regardless. Fireproof construction explains masonry. It does not explain the arched openings, which are more expensive and more labor-intensive than rectangular ones with no structural advantage in a load-bearing brick wall. It does not explain the carved stonework above entrance doors of facilities whose only visitors were maintenance workers. It does not explain why the interior proportions of these rooms, the ratio of height to width, so consistently match the geometry of basilica churches and diverge from contemporary factories of equivalent function. The civic pride argument explains why a municipal utility in Chicago or Baltimore might build grandly. It does not explain Racine. It does not explain the boiler rooms. The official explanation is almost convincing. Almost. Why did a technology with no historical precedent and no prior visual tradition reach so consistently for the oldest institutional architecture in Western memory? Before the grid existed in its settled form, that question had no building to attach itself to. In the 1870s and early 1880s, electrical energy was being explored in several directions at once. Charles Brush had powered public arc lights in Cleveland in 1879 using a local generator with no connection to any larger network. Municipal ownership structures were being tested in American cities. Local generator models, serving individual buildings, individual blocks, with no connection to a central facility, had been installed and were operating before any regional grid was built. The technology was open. The ownership structure was open. The question of who would hold energy and how it would reach people had not yet been settled. There was a moment just before the generating stations were built when electricity could have taken several forms. It could have remained local, distributed through individual generators, organized as a public utility, owned by communities rather than corporations. The technology had not yet committed itself to any single arrangement. Then one version finally won. The grid that followed was enclosed, metered, and centralized. Energy would be generated somewhere else, transmitted through wires that were owned and sold back to the people who used it. The alternatives were not pursued. By the 1890s, the direction had been chosen, not announced, not debated in any public forum that left a clear record, but chosen through the accumulation of investment decisions, franchise agreements, and infrastructure commitments that hardened across a decade into something that felt, afterward, like it had always been inevitable. The grid that emerged was enclosed. Energy was generated in central stations and transmitted through wires that were owned by the companies that built them. It arrived in homes and businesses through meters that measured exactly what was consumed. It was sold. The relationship between a person and electrical power became a commercial transaction, mediated by a utility company, governed by a tariff schedule, and interrupted the moment payment stopped. The atmospheric experiments were not funded beyond the laboratory stage. The municipal ownership models were absorbed or outcompeted. By 1910, the basic structure of electrical distribution in the United States had been fixed in a form that would persist, with elaborations but without fundamental revision, for more than a century. This was one version of what electricity could have been. It became, within a generation, the only version most Americans would ever encounter. The shape of the grid was settled long before most people understood it. The people asked to accept that arrangement had grown up in a world organized differently. They heated their homes with wood or coal they owned. They drew water from wells on their own land or from public systems they understood as civic infrastructure. They had no experience of a domestic essential that arrived through a wire from a central facility they would never visit, owned by a company they did not control, available as long as they paid and cut off the moment they did not. The new grid asked them to extend trust toward a system unlike anything they had trusted before. The buildings come back into the frame here. Consider the sequence. The 1870s and early 1880s, local generators, open technology, multiple possible arrangements. The 1880s, the first central stations built, the first franchise agreements signed, the first infrastructure investments made that would prove difficult to reverse. The 1890s, the central station model dominant, the alternatives no longer funded, the grid acquiring the legal and physical structure it would hold. The 1900s through the 1910s, the generating stations built largest and most elaborately, their architecture most fully committed to the vocabulary of civic monuments and sacred halls. The 1920s, Samuel Insull's holding companies extending centralized electrical ownership across 32 states and 12 million customers, the arrangement complete. Each step in that sequence was accompanied by buildings. The buildings grew grander as the grid grew larger. The architecture intensified at precisely the moment when the commercial and physical structure of centralized energy was being locked into place and when the public was deciding whether to trust what it could not yet see. A person walking into an American city in 1905 and encountering for the first time the local electrical generating station would have seen a building that spoke a language they already understood. The arches said, "This is an institution, not a speculation." The masonry said, "This has been here before you and will outlast you." The height said, "What happens inside exceeds the ordinary." The building was doing work the technology itself could not do. The turbines and transformers were incomprehensible to most of the people who would come to depend on them. The building was not incomprehensible. It had been designed, whether through conscious strategy or some deeper institutional reflex, to translate an unfamiliar system into a visual language carrying the authority of everything that had come before. These buildings were constructed at the seam between two arrangements of energy. On one side, energy had been local, tangible, owned, wood and coal and water a person could see and touch. On the other side, energy was centralized, metered, invisible in its transmission, and held by someone else. The generating stations were built exactly at the crossing point. They wore the face of the world being replaced to make the world doing the replacing feel continuous with what came before it. The grandeur was not celebration, it was persuasion during discontinuity. The generating stations of the late 19th and early 20th centuries are still standing in many American cities. The Fisk Street Station in Chicago, the Adams Power Station at Niagara Falls, the Pratt Street plant in Baltimore. Some have been converted into condominiums, into event halls, into museums. The machinery is gone, the arches remain, the vaulted ceilings remain, the 18-inch walls and the tall windows, and the proportions that no turbine ever required remain in stone and brick intended to outlast every arrangement that justified their construction. The grid they introduced is still running, the ownership structure they housed is still intact, and the argument those buildings were built to make, that the new system deserved the trust reserved for institutions as old as the arches above their doors, has been standing in plain sight for more than a century, waiting only to be read as the argument it always was. The buildings remember what the grid needed people to forget,